Good morning. This is the 7th lesson in the series of EKG understanding. Now in this lecture, what I want to tell few things before I start the actual description. The few things are that EKG learning is actually training your eyes at various variability. For it is essential to know first what is normal. If you keep in your mind normal, and if you find in the EKG which you are reading different, then you can understand the abnormality. You can go to the book, you can revise. So how to train your eyes for learning abnormal EKG? By looking at the EKG record in various books or in the strip or in the hospital practice or during monitoring of EKG. Now before we start looking at EKG, we should look at the name of the person, the age of the person, and gender of the person. Of course, the date should also be recorded on the strip and it should be noted. Then the three things I want to emphasize today. One is the heart rate, another is rhythm, and axis. Three things today we will be doing and I will be trying to explain to you. Normal heart rate, we know it varies from 70 to 100 per minute. And we know a high heart rate is known as tachycardia, a low heart rate is known as bradycardia. Now, how to calculate heart rate? Calculation of heart rate is done. You count the number of QRS wave during 6 seconds. 25 millimeter comes out in the machine in 1 second. So in 6 seconds, how many during 6 seconds, how many QRS complex are there? It is not difficult to count the second because each big square with the heavy margin is 0.2 seconds. So each one, big one, is 0.2 seconds. So accordingly you will find out so mark on the ECG first 6 seconds on the ECG and then count the QRS in this 6 seconds and multiply it by 10. This will give you the heart rate per minute. It's not difficult. This is one way. Another way is there is a fixed figure which you will learn from the speed. It has been calculated, that is 300. If you divide 300 by number of R waves, number of small squares in between R waves, how many average squares are there between the two R waves? So 300 divided by note the number of large squares between the R wave. Supposing if it is 4 large square between the two R waves, then 300 divided by 4, which will give you 75 per minute. So this is not difficult to calculate. Two methods you can apply. The first method is very good. Count for 6 seconds how many QRS are there and multiply it by 10. You will get per minute thing. It is good for irregular heart rate. If there is irregular heart rate, then you can calculate by 6 second method. The other method I have told you, 300 divided by the number of R waves between the two, number of the R wave, number of large square between the two R waves. Number of R squares between the two R waves divided by 4 will give you the heart rate. Now, Next, that is the second diagram, is about the axis of the heart. Axis of the heart means heart is not a straight hanging in the chest wall, inside the cavity of the chest, but it is mostly retroesternal and it is towards the left side. Now, the apex of the heart is situated in the fifth intercostal space, half an inch inside the mid-clavicular line. Now, this is the place of apex. Now, this can be pushed up towards the left side. If it is rotated towards the left side, it is known as left axis deviation. If it is pushed towards the right side, it is the right axis deviation. Now, normal axis is between -30 to 110. Now, let us imagine if you cut the thoracic cavity and see the heart hanging, then you can easily find out how much is on the left side deviation and how much is on the right side. So normal axis is 30 degree to plus 110 degree, while right axis is after plus 110. If it is over 110 and it is positive, then it is going to the right axis. If it is -30 and it is going towards the left side, that is known as left axis deviation. Now, see the right axis diagram of right axis deviation, how to find out. To find out right axis deviation or left axis deviation, you have to look at lead 1 or AVF or lead 3. It is better to, here in this diagram, it is shown relationship between lead 1 and AVF. If you make 4 quadrants, thinking that if you cut heart, thoracic cavity horizontally, then these are the 4 lines that you will see, one over each other, perpendicular. Now, each is 90 degree angle. And then what you see, find out how much deep is S wave in lead 1. How much S is deep in lead 1 in millimeter. So count here, it is 10 millimeter S and it is on the negative side. In this cross that you see, positivity is below indicated, negativity is above indicated. You can see it is written plus 90 and minus 90. Minus 90 is at the top, plus 90 is below. So if you draw, so this is here in lead 1, supposing it is minus 10. So on the minus side, if you draw and put a horizontal line from minus side, from R, S is 10 millimeter, 10 deep, and R is plus. So R is plus is horizontal line. Supposing plus is 10. So on the horizontal line, you put a dot on the right side, plus 10. And then draw a line that will be horizontally placed. Then you put another line that is S, that is on minus side. That means it is minus side on the left hand side towards 180. So if you put towards 180 minus 10 and plus 10 towards the positive. So R is positive, draw a line, horizontal line from plus 10, that means downwards. And then the S is negative. So right side of the horizontal line is positive, left side of the horizontal line is negative. So 180, towards 180 it is negative, towards 0 it is positive. So if you draw, and then you will find a cut point between these two lines, then you draw a line from the center, and the arrow will indicate the axis. So this similarly you can calculate, this is right axis deviation on the on first one on the left side that you see. Right side of the diagram, it is left axis deviation, and left axis deviation means again you have to look for 1. Now, where is lead 1? Lead 1 is horizontal line 0 to 180. This is lead 1. So lead 1, it is positive R. So lead 1 positive is up. Positive is up and negative is up and positive is below. So right side is positive, left side is negative. So now you see positive 10. You draw a line up, vertical, perpendicular. And then you see S is 10, minus 10. Minus is on the upper side of the scale. See, minus 90 written. Towards that you draw another line. When they meet, then you draw a line which cuts the point, and then that will be the axis of the heart. So here you will find the axis of the heart is about minus 45 degree. Minus 45 degree. This is how you calculate axis of the heart. In many conditions, abnormal condition, heart is on the left side, more on the left side. We call it left axis deviation. If the heart is more on the right side, this is known as right axis deviation. The third thing that I want to emphasize is about the rhythm. Now, when we talk of normal rhythm or sinus rhythm, that means every QRS should be followed by a P wave. When a P wave is there and there is a QRS, again there is a P wave, again there is a QRS, such type of rhythm is known as sinus rhythm. And in this, R waves are nearly equidistant. Two R waves are nearly equidistant, except for while you are taking a deep breath. Then I told you, when we inspire, the RR interval shortens, heart rate is faster. So rhythm could be regular, sinus regular rhythm could be tachycardia, fast heart rate, could be bradycardia, and could be irregular if the two R waves are coming at different time, variable, not coming on the same time, highly variable. So sometimes the irregularity comes regularly. So it is regularly irregular. When you find that it is totally irregular, irregularly irregular. So these are the things that I wanted to show you. And in the last diagram, which is handmade below, to find out axis, it is simple to remember. If all R waves in lead 1, lead 3, lead 1, lead 2, lead 3, all are going up, this is normal axis. If you find lead 1, S is going down, R is going up, they are meeting. Lead 1 and lead 3, S and R are meeting together. Then that is right axis deviation. In the left axis deviation, if you see the R is going away, S is going away in other direction, then we call it left axis deviation. I hope the diagram and details could help you to understand rate, rhythm and axis. This is for today. Another day we will continue how to read ECG. This is how to read ECG.